Hi everyone, my name is Joshua and welcome to Northern Solar. In this month's video we're going to be looking back at the facts, figures and financials for our solar installation here in Cheshire for the month of September 2023 as we continue to answer the question, are solar panels worth it? So quite a lot to get into as usual, so let's jump into the presentation. For those of you that are new to the channel, as I've always start off with a summary of the system, we've got 8 kilowatts of solar on our roof, so that's 4 kilowatts on the back of the house facing east and 4 kilowatts on the front of the house facing west. They're connected to a 6 kilowatt SolarEdge inverter, and with that we've got 13 kilowatt hours of Growatt battery storage. So September's production, as you can see, bit of a month of two halves. Started off with that lovely weather at the beginning of the month, loads of sunshine and hitting some really high numbers, over 30 kilowatts. 30 kilowatt hours of production in a few days, and then seriously tailed off. We still had a couple of good days. Generally later in the month it might sort of average days like just over 20, 25 around there, some good days, but in general some pretty mixed weather. So yeah, the highest we had early in the month on the 5th of September, 34.8 kilowatt hours generated in one day. The lowest all the way down on the 19th, that's 5.4 kilowatt hours, so a huge difference between the highest and lowest days in September. So total generation was 576 kilowatt hours for the month. That averages at 19.2. But you can see not many days were actually around that average. We had quite a few higher and quite a few lower, but not many were actually on that average. Just one there on the 23rd, which was almost average. So this compares the generation that we've had in total since we've had the system installed. So we started in 2022, which is the blue bars, in April. As you can see, we've had about 18 months worth of data now. So September 2022 and September 2023, a little bit lower than last year, 2% lower judging by the figures. September 2022 was 589 kilowatt hours and we had 576 kilowatt hours this time around. So yeah, it's sort of getting back to what we might expect. Last 2 months we were much below, like way below 2022's numbers in August and July. But then May and June we were well above 2022's numbers for 2023. So overall it's probably averaging out. It's hard to know because we still don't have that much data, but it seems like, yeah, September was pretty much as expected. So this is the data from our Octopus energy provider for what we've imported and what we exported to the grid, as well as our solar generation. So imported from the grid throughout the month of September, as you can see during those sunny days, not very much import at all. These days where you've got these large imports are when I've charged our electric car at home, so there's a big discrepancy. This is overnight charging on an off-peak tariff when we're adding around 20 kilowatt hours into the car. So as you can see, days when we don't charge the car, there's very little usage from the grid. What we've been doing is using the overnight grid to preheat the hot water with the immersion heater in the tank, but I'll go into that a little bit more later on. And then grid export, as you can see, early part of September, loads of export to the grid still, still practically summer levels of export, and then it's really tailed off towards the end of the month. Some days not exporting a single kilowatt hour. And as I'll go into that in a little bit later with the financials, the export is a big part of how we manage to save money and make money from our solar installation. So I picked an average day, the average day of the month, 23rd of September, so it's about just over 20 kilowatt hours of production in this day, and you can see we're getting into September, the days are starting later. It's around about 7:30 when we get the first light on the solar panels. Today, this day we're looking at, we've got a couple of sunny spells but pretty cloudy through the morning and around lunchtime, so a couple of spells where we're hitting 3.5 kilowatts of generation, and then it tails off into the afternoon, and by about 7 p.m. it's pretty much done in September. So yeah, as you can see, that's a pretty typical day, a few sunny spells and some cloudy spells. So the next slide shows that same day, but it also goes and shows our consumption pattern and how the battery is used during the day. So what we do is we start off at midnight here. This green box behind is the battery state of charge. Don't actually have a grid on that, but it's about 50%, and that would be 100% there. So as you can see, the battery feeding the small load, which is this sort of bluey purple colour, that's the load on the property, really low overnight. And then we hit our off-peak window, so we are using electricity from the grid when it's cheapest, because we want to preheat the water in the tank for hot water. So here, this is the hot water tank preheating. so that the water's ready for showers and such in the morning. Also, if we're charging the electric car, it charges during this window, so we don't want to discharge the battery out into the car so that the battery then is empty in the morning. We want the car battery to charge from the grid, which means that during this window we don't draw from the battery, we just draw from the grid. So that window closes, you can see, around 4:30 on the tariff that we use. The battery then continues to supply the load of the house through the morning, and then the sun comes up here and you see the charge of the battery start to go up. Here you can see there's some usage in the house, maybe the dishwasher or washing machine is on, and that starts to use some of the battery if there's not enough solar. As you can see, the solar is lower at this point than the draw or the load on the property. So the solar is this box here, this like sort of darker green colour. And as you can see, as the sun comes up, it starts to charge that battery. And what you'll find here, these sort of spikes that we're seeing here is once the battery gets to its higher capacity, like sort of 90%, it slows down the rate at which it can charge. And that means that sometimes there is excess power which can't go into the battery and would go to the grid. But what the first thing that happens is it turns on the immersion heater in the tank to reheat the hot water that we've used in the morning for showers and washing up and such things. So what you can see here is spikes in load on the house which actually mirror the peaks of the solar. So when the sun comes out, the generation goes up, which then increases the amount of power going into the immersion heater automatically. So what you can see there is that happens a few spells, and then by sort of lunchtime, 1:30, something like that, the tank is back to being fully heated, the battery is at 100%, so then we start to export to the grid. So you can see this blue graph here is where the export to the grid starts. And then there's a bit more usage in the afternoon, with things like kettles being on, again, dishwasher, washing machine, that sort of stuff. But as you can see, most of the time, whenever the sun comes out in the afternoon, it's exporting to the grid. What we've also got here is part of our tariff is Octopus Flux Tariff, which I'll go into again in more detail. But during this period, from 4 p.m. to 7 p.m, we're able to get paid extra to export during that time. So as well as the solar export, we also discharge from the battery. This time of year I've sort of limited it a little bit, because during the summer we'd export like maybe 50% of the battery every day to make extra money for the from that tariff. But what I decided to do in September was make sure we had a bit more in reserve for the evening, so I'd only discharge it down to sort of 60 or 70%, but it just gives you that extra bit of income from exporting during that peak time to the grid, which means that the tariff in that time is more generous. And then that window closes, and then the solar sort of ends around 7 p.m, and then again the battery starts to drain. You can see the state of charge coming down as we're using the battery in the evening for cooking and washing up, dishwasher, that sort of stuff. And then again, much lower load on the property overnight again. So obviously it's not the same for everybody. The way you use the solar and battery makes a big difference to how well it can perform in terms of finances and stuff, but it also depends on your usage in the house and what tariff you're on. And I'll go into that in a bit more detail in a later slide about how the tariff makes a huge difference to how much money you spend on electricity and how much you can make from exporting. So this is the sort of facts and figures for September from our solar and data from the energy supplier. So we produced 576 kilowatt hours, as mentioned earlier. We exported 273, and this is split out into these different periods of time where we get paid different amounts depending on what time of day we're exporting. So obviously overnight we don't exported anything as you'd expect, so we're not getting paid anything there. During the daytime from 5 o'clock in the morning until 4 p.m, we exported 126 kilowatt hours, and that's at a fixed rate. I will go into the details, but I think it's around about 20 pence per kilowatt hour. And then in this peak window for 3 hours from 4 p.m. till 7 p.m, we exported 147, and that's around double the rate that you get paid for. So that area there, that window, is much more lucrative for our export payments. And then again in the evening we're not exporting anything, we're using it all in the property, and the sun's generally gone down at this time of year at that time. So if you take into account everything we produced and everything we exported, that meant that we directly consumed 303 kilowatt hours of solar electricity in the property, whether that being using it at the time or charging it into the battery. We had 193 kilowatt hours of grid consumption, and as again this is split into these various regions. So what you can see is overnight and during the day, during the peak time and in the evening, the usage from the grid is almost zero, and the majority of our usage comes in that flux period, they call it, between 2 a.m. and 5 a.m. when energy is cheapest to buy for us. So it's about 18 pence to buy at that time of night, and then all the other times during the day it's more expensive. So what we do here is charge the electric car, we heat the hot water in the immersion tank, and if there's not much charge in the battery, say we've used a lot of it the day before, we can add charge into the battery during that flux window, and it's a lot cheaper. So if you add the grid consumption and our cell consumption together, you get 496 kilowatt hours of electricity consumed on the property, including electrical usage, hot water heating, and charging the electric car. And yeah, so what I do as well is I split this down into peak and off-peak consumption, because these windows can be quite confusing to try and put into a nice simple pie chart. So when you look at the peak being everything outside of that off-peak window, so you've got a total of 10 kilowatt hours there and 183 in off-peak. Going over to the financials, what we try and do here is we show you exactly what it's cost us, but also compared to what it probably would have cost us if we didn't have solar. So our standing charge for the month of September was £18.05. Our grid usage cost for those 183 kilowatt hours overnight and the 10 during the other times of the day cost us £41.80. So a total electricity cost of £59.85 for the month. If we didn't have solar, the standing charge obviously would be the same. Our cost for grid usage would have been a lot higher because we wouldn't have had the solar to use. So we would have had £102.40 of grid used solar, which means a total electricity cost of £120.46. So this is where the difference comes in. Obviously you haven't got solar panels, you're not going to get any export earnings, but we managed to make £85 in September from export earnings, £85.20, which means a net electricity cost of negative £25.35. So in September, even though half of the month the weather wasn't very good, our electricity bill was still negative for the month of September, whereas it would have cost us £120.46 if we hadn't have had the solar. So our monthly savings compared to not having solar is £145.81 for the month of September. Breaking down how we've used the electricity that we've generated, we've exported 47% and consumed 52%. So that generally seems to be pretty similar throughout the sort of summer and autumn and spring months, where we're generating more than we need really on a good day. So a lot of it does go out to the grid, but as you can see, we do make money from that. So it's not wasted at all. We do make money from those exports. And as you can see from the usage breakdown of our total consumption in the property, the consumption of 496 kilowatt hours, 61% of that has come from the solar. 37% of it comes from the off-grid, from the grid during off-peak times, and only 2% comes from the grid at peak times, which to me is really good. Like we're not using the grid at peak times when it's most expensive and most carbon intensive on the grid. We're using it during the off-peak, where it's cheaper for us to charge the car, heat the water, and charge the home battery if we need to. So this is the sort of rates that we get on our Octopus Flux Tariff. The standing charge in our area is just over 60 pence a day, which is stupidly high, but with nothing we can do about that. That's whether you have solar or not, it's just really high standing charges around here. The day rate import is 31.1. The flux rate, which is that sort of cheaper import rate overnight, is 18.66. But if we want to use anything from the grid between 4 p.m. and 7 p.m, it's 43.53 at that time. And on the flip side, if we're exporting at any point during the day, it's 20.1 pence. Obviously overnight exports, it's not very lucrative to do that. You don't really need to export. That's generally when we're importing. And then if we export during that peak window in the evening from 4 to 6 p.m, it's 32.53 pence per kilowatt hour, which is over 50% more than during the day. So that's why we save up the energy in the battery and then discharge it to the grid at that time, because it's worth more for us and it's helped us make more money and save more money and actually make money again this month by having it set up like that on this tariff. So this table gets bigger and bigger every month. It's starting to get very difficult to read. Essentially this is every month's data since we've had the solar installed. I do keep meaning to simplify this a little bit, but it's nice to see it all in one big line. There is a link in the description to a version of this which you can use for your own purposes if you want, and repurpose it or see how it all works, check the formula and everything like that. But essentially it's that same data we showed earlier on, just in a table form for each month. And what's the easiest thing to see is how these have changed over time. So this is our usage, consuming and exporting. So when we first started, we didn't have a battery, so we exported a heck of a lot more. You can see 75% was exporting. But since then, we had, through this summer, we were exporting more than 50%. As you get into the autumn, you're exporting less and less because there's less solar, and then in the winter, again, you're not exporting very much. The percentages of what you're generally using, what you're generating at the time, or charging the battery, so less of it goes to the grid. And then as you can see, coming out of the winter, you start to export more. The percentage of export goes up and up and up into the summer, where you're generally exporting quite a lot. We had a really poor July and August in terms of generation this year, so I think that the numbers aren't as obvious in the summer this time, but you can see like the early summer, sort of May, June, we exported a heck of a lot. And also it makes a difference how your usage patterns change. As you can see, the first month's a bit of an anomaly with no battery. We still had to use quite a lot of peak time grid usage because we didn't have a battery to store the energy to use later in the evening after the sun had gone down. So as you can see, without a battery, you're using a lot of peak time grid energy. This section is where we were using pretty much everything from the solar, nothing really off peak, very much because we didn't have an electric car at that point. Then we had a plug-in hybrid car, so you can see we're starting to charge the car overnight more. We were not working from home, we were out, at this point we were working from home, so we weren't out that much, not charging the car very much. And then here we were not working from home as much, so we were charging the car more overnight. So you can see a lot more overnight grid usage off peak, and as you come into the autumn and winter, you're using a lot more, charging the car a lot, and then charging the home battery a lot. And again, you can see that starts to change as you come into spring. It goes the other way again. You're using less on the off-peak because the solar's helping you out more with your usage during the day, charging the battery. We have had a few odd months where it's been a bit different. If we've done a lot more miles now, we have 2 plug-in cars that we charge a lot more occasionally, but most of my charging is actually done at work, but I'll go into that a bit more later. But yeah, in a quick summary, overall the numbers here are starting to add up to a really nice figure. We're just short of £2,800 in total savings since the introduction of the solar in April 2022. So moving on again, financially, comparing September 2022 with September 2023. So this is quite interesting. Generally, it was pretty similar in terms of production. We exported a little more this month in September rather than last year in September. We consumed a little less. We consumed less off the grid than we did last September. And again, a little bit less off the grid in off-peak mostly. So overall, our consumption was lower. We generated less, but our consumption was lower. So these splits are not too different, how much we consumed and exported. And again, these usage breakdowns aren't too much different in terms of percentages. The numbers are fairly similar, but the graphs and the pie charts there show a similar sort of usage of what we had generated and what we bought in from the grid. The big difference is how the financials are calculated. If you look at the monthly savings, they're vaguely similar, only a couple of percent between them, but it's very differently stacked up. Last year we were on a standard sort of peak off-peak tariff where we got a flat rate for our exports of around 5 pence, I think it was, a very low export rate, but we were getting a low rate overnight for 4 hours. I think we were paying 7.5 pence or something like that. So our standing charge is a lot higher now, which can't really do anything about, but that's just one thing. Our cost for our grid usage now is a lot higher on this Flux tariff because we're spending a lot more for what we need off peak overnight to charge the car, heat the water, charge the batteries, that sort of stuff. So we've spent double the amount on the electricity. The actual amount we used from the grid was lower, but it cost us double. And then you look at, so the overall electricity cost is a lot higher, but we're exporting, as you can see, we exported about the same, maybe a little bit more, but we got paid 8 times more for our exports this month compared to this month last year. So the difference overall is about £50 net electricity costs. So when you see what it would have cost us with solar and what it would have cost us without solar, the difference is quite interesting to see. Just the tariff will change how it looks, but the overall savings are pretty similar. But what it then kind of leads to is it's all down to how you use it. What tariff works best for you in your use case? What do you need to do to get the most out of your solar? And that's one of the key things that we've come to learn is the solar and the batteries and the EV car and the heated hot water and all of these things are great tools, but you have to pair it with the tariff that works best for your use case. And we've changed tariff a few times to try and make the most out of it, and through the summer this tariff for us, the Flux Tariff, has been fantastic. September it looks like we've pretty much come out the same. We've saved a little bit less, but we've also used a little bit less, so you could kind of say, well, if you've used less consumption in total, then you would have saved less, because the difference is where you've saved the money is where the more you generate, the more you save, if that makes sense. So we've done worse this year compared to last year, so we've saved a little less. But yeah, it really is down to how you use the energy and what tariff you use to combine that to make the most financially suitable for your use case, really. So everybody asks about payback calculations. It's really difficult. This is based on our first full year of data, where we saved just shy of £1,500 based on our calculations. Again, this table is in the link in the description if you're interested in how it all works, but essentially I plug in a whole bunch of assumptions based on tariff import rates, how much we generate, how much we think we use, how much we export, and all of these things, and it generates then all of these figures for the year one, and then extrapolates them based on inflation rates, which, as we all know, you might as well put your finger in the air for inflation rates these days, and degradation of solar generation, because obviously your panel degrades a fraction each year. And what this all kind of boils down to is that the £15,000 that we spent on our solar system, we're hoping for that to be paid back within 8 years, basically. Whether or not that's accurate is really hard to tell, but everyone always kind of wants to know how quickly it will pay for itself. So we did this calculation to give us an idea. And then again, at the end of year 2, I'll be able to update this again with another number of how much we're going to have saved, and maybe start to update some of these assumptions, but hopefully less than 8 years, and our system will have paid for itself, and then you can project it as far forward as you want of how much it's going to save you. But if it saves us £93,979 over 25 years, I think it'll have done a pretty good job, but we'll have to see how well that goes. I mentioned earlier we have an electric car. This is the Renault Zoe that I use. This month in September I drove 1,043 miles, an average of 4.5 miles per kilowatt hour. Total charge into the car of 196.9 kilowatt hours. Not very much of that done at home, because I get to charge it at work, which is what most of my driving is for, to go to work and back. So 28.9 kilowatt hours charged at home at a cost of £6.02. Work charging 0, but 168 kilowatt hours put in at work. So our overall cost per mile worked out at 0.6 of a penny per mile, which is pretty staggering, really. I do mention this pretty much every month, but I'm staggered at how cheap it can be. I do understand that I'm very lucky to have charged this car at work for free, but the main reason I got this car is kind of for that reason, is I can drive to work and charge for free at work. Even if all of the miles were done at home charged, the savings would still, the cost per mile is still very low. Even if it was 3 or 4 or 5 pence per mile, it's still incredibly cheap. Petrol prices have also gone up this month significantly compared to August. So if you're assuming the same amount of miles at a 40 mile per gallon average petrol car, £1.54 per litre this month, that would have actually cost £182.55 to do that same amount of miles. So my costs of £6.02 meant that realistically in July, driving this car saved me £176.53. And again, I understand that electric cars are more expensive than petrol cars, but it's quickly proving itself to be very worthwhile investment for me. So the last thing that we have in the house, which I've mentioned earlier, is this energy heater. So this is the Eddy from My Energy, and what this does is it takes any excess solar that it sees going back to the grid and automatically turns on the heater in the hot water tank that we have. This heater is just an electric immersion heater, and it's got it works variably. So if there's up to 3 kilowatts going out to the grid, it can take all of that energy and heat the hot water with it. And then once it's hot and reaches a temperature, it turns off and the energy goes back to the grid. This actually doesn't really save us any money, because at the moment it's cheaper for us to buy the electricity overnight to heat the hot water. If we buy the energy overnight, it costs, as you can see, 18 pence to buy it overnight. If we export during the day, we get 20 pence. So, well, 18.6 pence and 20.1 pence. But what you can see is the difference is just over 1 penny per kilowatt hour difference between exporting during the day and importing it at night. So if we put it into the hot water tank during the day, we're losing 1.4 pence for each kilowatt hour that we do that, because we could be exporting it and then buying it back at night at a cheaper rate. So actually this month we put 96.8 kilowatt hours of solar energy into the hot water tank, which actually ends up costing us £1.39. And a lot of people would say this is silly, you should just not use it, you should just heat the hot water overnight because it's cheaper. And that is true, but what I've found is I actually prefer it like this, because it means the hot water is heating during the day. If we've used it in the morning, that means there's more hot water in the evening if we need it. And it also feels better to be directly using the solar that we're generating on site, rather than pushing it back to the grid and then buying it back later. Ideally, we don't really want to buy anything overnight, but when we need energy to go into the car and we need energy to go into the battery to be ready the next day, that's unavoidable for us. But to heat the hot water, if we can do it during the day, it saves us having to use the grid. It's just trying to make us a bit more self-sufficient. And as you can see, every single day pretty much, other than some really terrible days maybe around here, there's energy going straight into that tank to give us the hot water. So yeah, that's the last bit of tech in the house when it comes to solar and batteries and such. The last thing I generally do, as you probably know if you're watching these videos, at the end of the video, is to give myself a little plug for Octopus. I've been with Octopus for a while. If you are considering switching to a different tariff, if you're looking to get best sort of tariff details and deals for solar, green energy from the grid and batteries and exporting like we do, Octopus to me are without a doubt the best option there is. I don't work for them, but if you want to move over to Octopus and use our referral code, you'll start with a £50 credit on your bill, and it will also give us a £50 credit on our bill, which to be honest is amazing. The people that have signed up for it, it's been a massive help to us. It's going to help us pay our bills during the winter for gas and electricity. So yeah, just a little plug there if you are interested in switching over to Octopus, and I highly recommend you look at it if you're interested in electric car charging, solar, batteries, all of this sort of stuff. Do check them out for their variety of different tariffs, which will help you get the most out of those technologies that you're going to invest in. So that's pretty much it. So switch back to the camera, and as ever it's gone dark while I'm on the camera, so let's just make it a bit brighter. Yeah, so that's pretty much it. That's all the details, all the facts and figures, and I think we can, as ever, say, are solar panels worth it? As ever for us, the answer is yes. If you've got any questions, any comments about the presentation, about how your solar is performing at your house, do let us know. If you're looking to get solar, ask questions. There's loads of people in the comments that have got some good solar knowledge and generally quite helpful at putting their opinions forward. Always love answering the questions, especially from people around other parts of the country and around the world, how solar works for you in your house or even your business. If you're interested in anything like that, do drop a comment in. Always enjoy reading them. But that's pretty much it. I'll see you guys next month. Thanks very much.